How are reptile skulls different? If you've ever wondered what makes reptile skulls unique, you're about to uncover some fascinating differences. Let's start by comparing them to mammalian skulls, as this contrast will help highlight the distinct features of reptiles. One of the most noticeable differences is in the structure of the skull itself. Reptile skulls can be categorized into three main types: anapsid, diapsid, and euryapsid. Anapsid skulls, found in turtles, lack any temporal openings, meaning there are no holes behind the eyes. This results in a solid, rigid skull that provides excellent protection and is well suited for compression feeding. On the other hand, diapsid skulls have two temporal openings on each side of the head. One opening is above the postorbital and squamosal bones, and the other is between the jugal and quadratojugal bones. This design allows for greater muscle attachment and flexibility in the skull, which is beneficial for powerful biting and efficient feeding. Most reptiles, including lizards, snakes, and crocodiles, have diapsid skulls. The euryapsid skull is a variation of the diapsid type, but with only one temporal opening positioned high on the skull. This type is found in extinct marine reptiles like ichthyosaurs and plesiosaurs and supports adaptations for an aquatic lifestyle, such as streamlined skulls for swimming. Another significant difference is in the lower jaw articulation. In reptiles, the jaw joint is formed by the quadrate bone in the skull and the articular bone in the mandible. This is different from mammals, where the jaw joint is formed by the temporal bone in the skull and the mandible. This change in mammals allows for a wider range of jaw movements and stronger bites. The middle ear bones also differ significantly. Reptiles have only one bone in their middle ear, the stapes, whereas mammals have three bones, the malleus, incus, and stapes. The malleus and incus in mammals are derived from the articulate and quadrate bones found in reptilian skulls and mandibles. Additionally, reptile skulls often exhibit cranial kinesis, especially in lizards and snakes. This means their skulls have movable joints that allow for greater mobility and the ability to redistribute bite forces, which is helpful for capturing and eating prey. In summary, reptile skulls are distinct due to their varied types, such as anapsid, diapsid, and euryapsid, each with specific adaptations for different lifestyles. The differences in lower jaw articulation and middle ear bones further set them apart from mammalian skulls, highlighting the unique evolutionary paths these groups have taken.